Instruction to the participants. Kindly ensure that your video and audio are muted after connecting in Microsoft Teams. At the end of this session, question and answer feedback link will be posted. For getting a e-certificate, you have to fill it. The link will kept open only for 1 hour after the completion of the session. So on behalf of K.S.Rangasamy College of Technology, Tiruchengodu, Tamil Nadu, I extend a hearty welcome to all the participants for day 1, session 2, and today's our afternoon session guest speaker, Dr. Saravanan Varadaraju, software architect, Siemens PLM Software, Pune. I welcome you, sir, to deliver speech on CAD/CAM, CAE, and additive manufacturing for 1 week faculty development program on mechatronics engineering for Industry 4.0 era. This FDP is jointly and proudly hosted by Mechatronics Department, K.S.Rangasamy College of Technology, Tiruchengodu, and Institution Innovation Council, Ministry of Human Resource Development Initiative. Now I request Professor Dr. N. Thiruvenkatam from Mechatronics Department to introduce our today's speaker, Dr. V. Saravanan, sir.
Yes, sir. Thank you, sir. Very good evening to one and all present here. It is my pleasure to introduce Dr. Saravanan Varadaraju, Software Architect, Siemens PLM Software, Pune, India. He was completed BE Production Engineering in 2003, ME Production Engineering in 2005, PhD in Mechanical Engineering in 2016. All are studied in PSG College of Technology, Coimbatore. He has 12 years of experience in CAD, CAM, CAE, PLM software development, CAD features and geometric modeling, developing production system simulation software, developing CAE pre and post processing software. He has good knowledge on geometry and topology, developing Unigraphics, NX, open APIs for customization, experience in Pro-E customization using Pro Toolkit, managing complex projects with various teams, experience in all stages of to maturity, research experience in new composite materials and development. So he also has obtained various languages and architecture skills like C, C++, XML, OpenGL, COM, CAA, design patterns, data structures, and tools like Treeforce, Visual Source Safe, etc. and code management in Pro-E, CATIA, AutoCAD, Simula Abacus, ANSYS, Delmia, MATLAB. Also, he has received Rookie Award in 2011 for Best Performance, Siemens Quality Champion 3 times for helping target, then Team Performer Award in Siemens Hackathon 2014. Consistent Performance Siemens MCAD Award in 2019. He has worked in Dassault System Engineer for 1 year, Altair Chennai for 3 years. Also, he has published 9 reputed international journals. Again, I am very much happy to introduce such an eminent person, Dr. Saravanan Varadaraju from Siemens. Thank you so much for giving an once again. I welcome, sir.
Thank you, sir. Participants, stay tuned with the be started in a second. Now I request Dr. Saravanan Varadaraju, sir, to go ahead.
Thanks for introducing me, Dr. Thiruvenkatam, sir. Today I am going to discuss about CAE and additive manufacturing and advancement in this field and its contribution in to the Industry 4.0. So the agenda today is I will introduce what is CAD, CAM and CAE softwares, and PLM software, and about additive manufacturing and opportunities in this area. So as we know, what CAD CAM CAE software, yeah, we are using last few decades this software for various our application for designing and analyzing. So we know this CAD CAM and CAE softwares are used for creating a model and developing and analyzing and optimizing the 3D models. So basically, we know this is a computer technology. CAD CAM CAE is nothing but a computer technology. So it will solve many of our design and analysis problems. And so we also we might encountered various CAD CAM CAE software in our day-to-day life. We might design some components in real life component, and we did the assembly and analysis, all those operations we might perform it. But so there are industry scenario is ultimately it is higher than what they expected. Always there is a research and development is going on in real industries, and they always looking for advancement in this area. So what we know is we will create a sketch, and we will create a block, and we will create a secondary features, like we'll do some cut, and we will do fillet and chamfer operation. That's what we understand, that is a CAD model, but it is not this much. There are lot more things. Yes. So initially, if we see 1 or 2 decades before, we will use blueprint drawings. The blueprint drawings will be the very big. They will manufacturer will see that blueprint drawing and do operations in the lathe and create the models. But today, if we go any manufacturer, they mostly won't use blueprints because the advancement in these areas are high. So the reason, if you see 1 or 2 decades before, CNC evaluation is bring this CAD CAM systems up. Not only CNC brought this CAD CAM system up, other systems like computer hardware, software, all those are contributed to CAD CAM CAE applications softwares to bring to this level today. Say we might seen the visual example. So in olden days, the car will be square shape, or a truck or van or lorry will be square shape, and it will not be not at all aesthetically good. So it will it is a purpose, it will be solved, like it is, you can move anywhere, it will transport. Still the performance is not that much what we are achieving today, but today's requirement is aesthetically it should be good. So you can see right side the car, what is the it is not easy to create this kind of design. So there are a lot of operations involved in this kind of design, lot of mathematics involved in this kind of design. So if you see the first car, it is like a point to point continuity, that is enough to make this kind of design. But if you go to the another one, then modern design, so you need to go to continuity of higher order continuities. So either it can be curvature continuity or tangent continuity or like that. So these are achieving to in a software is a very big challenge. So because of this, we so far we encountered this much challenge, and we could make this kind of outputs. So not only that, it is not only aesthetically looks good, it has a good performance. So if you see olden car, it will give only per liter petrol, it will give only 10 kilometers or 8 kilometers. Nowadays it is giving more than 20 kilometers. So that is the performance. So it is lightweight, the materials are different. So for all those things, these kind of software's contribution is too much. It is contributing so much on this kind of technology, so that only it could be possible. Say it is if you see any CAD software or CAM or CAE software, we cannot see that is alone for a design or analysis purpose. It is providing a system. So if you take a car, there are so many systems are involved in that. So it is not only design involved in that. So there are so many systems. We need to make sure the assembly is proper, and we need to make sure the control is proper. All those things involved in that, it becomes very complex systems. So in that kind of complex system, only one engineer is not enough. So if I am say I am a design engineer, that is not enough to solve that problem. It should be there are multiple collaborative design should be possible. Then only we can achieve these kind of complex systems. So it involves mechanical, electrical, production, mechatronics, and software. So there are so many softwares running inside that. So next there are automotive guided guided vehicle is going to come. So it will automatically drive based on the programmed instructions. So those things are all not possible without this kind of software technologies. So say for example, if you see this assembly, if it has so many parts, at least it might have 1,000-2,000 parts inside it, and we need to check the tolerance analysis. So there are a lot of moving parts. It is not statically holding the loads. It should move, and at the movement it should reduce. It should have a less friction, and it should have high performance and less weight. All are the target. So then only we could get the final output. So we need to analyze all. Design is not only enough. We need to do all the analysis. So nowadays, if you see 5-10 years back, the software, anything like a top softwares like a Unigraphics NX or ProE or CATIA, it will have only features to develop a CAD model. Just you can make a CAD model and do assembly. But nowadays it is not for a CAD only. It is used for many other reasons. So all those are important to the modern industries and modern requirements. So to achieve that, so definitely we need to collaboratively work. So no one engineer or one stream of engineer cannot solve the purpose. So there should be multiple people involved in that. All multiple people has to work together. So that's why software itself, today's software, if we go, we used to say it is a collaborative design. So that means customer will ask something, and the designer will do some design, and the functionality designer someone will they will say this should be the final output. So all people has to work together, then only it is possible to achieve this kind of high-tech design or high-tech output. So I will show simple videos, just 1-minute video, how collaborative design is working.
Sir, Saravanan sir, kind request, sir.
Yes, sir.
Your audio is not clear.
Okay. Video
While
is clear, sir.
playing it. Yeah, video is clear, but audio is not coming.
Okay, this is just 1 or 2 minutes. I have 1 or 2 another videos, but it is just 1 minute video. Okay.
Okay.
So
Okay, sir.
I will continue. This is not only with CATIA software. It is all, most of the big software has all this architecture. Internally, it will allow people to collaborate and do design. So initially we know basic surface modeling, solid modeling, but it is not enough. So the surface modeling and solid modeling in a part, one single part if we take surface modeling and solid modeling together is not enough. So we need to have a finite element model. That means it should be a meshed model. It is discretized model. We used to say discretized model. So it will be a triangle or quad shapes. So for analyzing this is required. So I am interested in only this area where I want to do some analysis. I don't care about other assembly parts. It is costly. Even if you performing go to analysis software, then it will be costly. It will take in months and it will take many designer and engineer for CAE engineer for doing that job. To avoid that, we can in same model it is possible to create a meshed model, discretized model and analyze. That is possible. So these kind of options are already coming in the CAD system. So these CAD CAM CAE softwares are not only useful for designing or automobile or aerospace. It is used in other applications. So if you see in CAD term, what we used to say, if it is a mechanical application, then it is a MCAD. If it is an electrical application, it is a ECAD. So like that it is classified. So it is architecture. We can be used this the building strength, and it is used in architecture and PCB manufacturing and design. It is possible. Say for example, there is a oil well or petrol resources there. Even human cannot enter sometime because it is dangerous or it is not allowed. So there we have to manage. We will put some sensors and we will design it in the same system in the software, either reverse engineering or and monitor those systems are working properly or it has some problem. So those systems also should be available in this software. So that's what today's scenario things. So if tools initially, yeah, manual will be in blue color. We might see at our school days, or and then it is increased. The famous 2D drafting tools are available. Then 3D comes in, and now it is going away. Actually, earlier, if you see 3D model, we have to fed into CNC separately. Nowadays, not required. So we can connect this software to CNC machine. It will make that components. Now the next level is like additive manufacturing is coming in. So it should these softwares, CAD, CAM, CAE softwares should satisfy the additive manufacturing requirement. I will go through those things in coming slides. So we can design anything, but if we design by human being, then the design will be it will not be possible to this kind of design. See, this bike has some what do you say, normal, it is not a normal design. It is a abnormal thing. Human being cannot decide these things, how to make this kind of design. But today's industries are making this kind of, either automobile or aerospace, any stream, they are using these kind of designs. So to make this kind of design, software should be ready. How it is possible? Yes, it is possible. So it will do generative design. That is called generative design. If you give what is my output, what is my code I will apply, and this much output should be there. Say for example, I have IC engine, so I know this much output should come, and this is what my input. If I say the then it will automatically design your IC engine. So that is the capability these softwares are taking up. So I will, this is again another video I have quickly how these, so it is not necessary any audio, so you can just see how it is possible to design these kind of things. It is iterative process, even human being cannot do that. It will take of years to do that. So but if you give it to software, then it will change the design and it will go for analysis and it will check whether my analysis is satisfying my requirement, if stress strain or it with limited with the limit or not. So if it is not in limit, then it will change the design again. So it will perform multiple steps, multiple design steps, then only we can achieve these kind of components. So just quickly I will play this. So this is just you designer did some basic design, then give it to the here. So it will change the design and to CAE analysis, and it will perform the CAE analysis, and final validation will be it will check whether it is acceptable or not. Internally it may use non-traditional algorithms like a genetic algorithm or neural network, like that algorithms it will use, and it will find out whether the output is meeting the objective or not. Then it will perform again from the design. It will change the design and it will do CAE analysis and it will check the output result whether it is meeting the output or not. So like that it will perform multiple steps, result, fruitful result. So that kind of performance are the options are available today. So just I will close this. That's all. And okay, so now CAD model is concerned. We will see CAD model only. So what are its application? So CAD model we can use it for CNC manufacturing and additive manufacturing and automation. So if you want to do some automation and analysis, then it is useful, and it can be used for visualization and simulation and analysis. So this just a CAD model is applicable or useful for downstream industries. So for example, even if you see any electronics component, there will be some analysis, thermal analysis. So it will generate a heat when we are talking in a phone. So it will generate a heat inside that. So it should withstand the component, the material should withstand those heat. Suppose it is falling down, so it should withstand if it is falling down. So softwares will do drop test. It is specifically called as drop test. Once you drop, it should not affect internal components. That's how they design it. So and a lot of other internal testing will happen virtually before going for manufacturing. So as I already mentioned, so this CAD model can be used for many other downstream applications, CNC and rapid prototyping and automation and checking the design details like that. And not only that, aesthetically we will visualize where it is okay or it needs some changes, like that we can visually evaluate those things, and finally we can simulate using the finite element softwares. So these are all, it is we cannot separate. So nowadays, earlier it used to be separate softwares like CAD software is separate, and CAM software is separate, and CAE software is separate. But nowadays it is not like that. It is all are one platform, it coming all softwares. If you see even these big companies like if you see ProE, we know because we might use it in college, right? So if you see ProE, PTC is the parent company. They have 20 other products. ProE Creo is the latest CAD modeling software. Similarly, they have finite element analysis software, they have CAM software, everything. Similarly, Siemens is concerned, there are CAD software, CAE software, and PLM software, etc. So each company, it is CAD software is not only enough. it needs other applications also, and also all are integrated in one single software based on user's license. It will behave. So in one platform, one UI, user can perform all the operations. That is the today's software. So if you see CAD CAM, so CAM means we know computer aided manufacturing. It is this computer, how computer is useful for the manufacturing. So but we will come to my first point. We will come to that CNC is the CAM software, and TM it is used for CNC and manufacturing. But not only that, there are a lot more than in manufacturing, say plant simulation and finding out the bottlenecks in the resources, and how to run the factory in a virtual mode into CAM softwares. So there are very well even it is now big industries use that kind of softwares, like a Delmia kind of softwares. That is, even license cost is very high, and it cannot be used outside single person unless otherwise it is a company. So those kind of softwares, for example, I will show you one small video again, so how CAM software is used. So these kind of things, before going for the plant implementation and actual production, the people or industries will do all analysis, any bottleneck resource, even human beings. So there is a module called human. We can model the humans and we can give the input, how much he is efficient, how much he can bend, how much he can take, how much load he can handle. Like that, we all the input we can give, and we will find out how many human beings are required, how many machines required, how many assembly lines required. All those things it will be pre-planned before entering into the actual production system. So those things are possible with this softwares. Okay, so now we see in CAD, CAM, CAE. Okay, so we are generating lot of data. It will be in GBs, right? So GBs, TBs. So how to handle those data? So if there are multiple engineers working on that, how to handle that data? So there is a PLM software will come into picture. Say for example, this PLM software, like this team, Siemens has Team Center, and Dassault has Innovia, and this PTC has Windchill, etc. So each big CAD systems have internally their PLM softwares. This is a specific software which will handle internal data. So these will handle very smartly those with the use of these PLM softwares. Without any headache, we can easily go ahead and manufacture the components. So it will take care of the life cycle of the component from the raw material to the supplier, and not only to until the supplier raw material, and it will manufacturing also. It will keep note of each product will have some IDs, and after that it will deliver to supplier, and we know which supplier using this ID component, and not only that, after that also life cycle of the component it will take care. So how much it is withstanding, how much time it will withstand that component, like that. So then again it will be performed like artificial intelligence, those kind of analysis will be performed, and how to improve that life cycle of the component and what material we need to change, all those analysis will. Okay, so next, these CAD CAM CAE softwares, so far till last decade, till we can say 2010 or before that. So it is mainly used for the downstream application, which I mentioned earlier, like it can be used in CAE analysis and CNC manufacturing and automation, etc. So those things are decided how this system has to develop or evolve. But now the additive manufacturing has given a lot of capability. So earlier we might seen some subject will be there in the engineering, that is design for manufacturing and assembly. That means we have to design any component in a system and a software that considering how it can be manufactured. Otherwise that design is false. Design, even software itself has, otherwise, say for example, I have a small entering into that, and that design in lakhs. So those, to avoid those kind of things, always we will say design design for manufacture and analysis assembly. So now another term comes, design for additive. Design itself will change. The design itself will change between normal manufacturing and additive manufacturing. So that is the difference. So nowadays, now if you see current scenario, additive manufacturing has more capability than design softwares. So design softwares or CAE softwares taking its own value to the additive manufacturing, because additive manufacturing, though there is no design constraints, you can manufacturing anything. Design is not a constraint at all. Yeah, still there is a 10%, it is there, but not as like earlier conventional manufacturing. So to achieve that, these CAD CAM CAE softwares to come has to come long way. So still the softwares are working on that. So you might hear the additive manufacturing is nothing but 3D printing. Earlier it used to call a rapid prototyping. There it is not one type. There are so many types, around at least 20-30 types of there of the additive manufacturing are there. Yeah. So these I am just highlighting. I am not going in depth on each type. So some basic types I will give you some basic intro how it is working. So say for example FDM, future deposition modeling. So if this is concerned, we can use even at home, even at our office, we can have a printer and we can make any component and we can prototype it. That is the possibility. Earlier it is not at all possible. Without this technology, never ever possible. This kind of we cannot do any prototyping, we cannot make a new component. It will be possible, but it will be very high cost. We have to make a card, we have to spend lakhs for making dies and manufacturing those things. But nowadays it is possible. So within few thousands we can find a machine, we can buy a machine and we can make a prototypes. So that is possible at home itself. Even our kids can play with that. We can improve our kids innovation. So there are again, so it is not all together. We cannot say all will solve, one machine can solve all the purpose, one technology can solve all the purpose. So there are many types of 3D printing available. Say future deposit modeling, it mainly works with the plastic material, and it will work extruding the plastic material by some heat. And stereolithography and DLP, digital light processing, both are it will work same technique except light source. So it's stereolithography will use laser and DLP will use ordinary UV lights, like that. So it will have more precision. It will work based on resins, not instead of plastic. So it will layer by layer. So why we say all are additive manufacturing when there are so many additive manufacturing technologies? Only one reason: all are creating models by layer. That is the only one common thing. So that we say it is additive manufacturing or 3D printing. So except each one has, even machine is different. Each have, even FDM itself, there are multiple types of machines. So again, SLA or DLP has different types of machines. So this is material jetting. So this is another fantastic technique where you can you can jet the material. You can we can jet the material particles. That it will be like a ink tank will be there, like we have ink at home, ink tank printer. So it is similar technology. It is used for making the component. And selective laser sintering. So again, this will use powder as a raw material. Either it can be it will use for both plastic as well as metal powders. So those metal powders will be diffused by lasers, and the next layer of powder will be coated, and again it will solidify those section of material. Then it will repeat the process until the final component is arrived. So so each one has some different advantages and disadvantages. So we have to choose which one we are going for. So this is actually SLM, selective laser melting. Again, same, it will melt based on laser thing. And instead of laser, we can use electron beam for melting the powders. So it is used to say electron beam melting. So, and sand binders jetting. So it is kind of sand particles can be binded. So we might see in foundries or the casting. So now those making that outer sand mold is possible by 3D printer. So even it is available today itself for making those sand molds. It is working with the sand binder jetting. So this is another technology. Okay, so there are so many technologies and so many materials. So either it can be aluminum, steel, or plastic, ABS, or it is either it can be PLA, alumina, zirconia, a lot of things. So still it is not additive manufacturing not supporting for all the materials. It is supporting as conventional manufacturing supporting. So it is evolving day to day how to support. So why we want to go for additive manufacturing? There are a lot of reasons. If material is concerned, I can say one reason is, say, if we see aircraft component, it is very costly. If we take titanium, zirconium, cobalt, these kind of materials are very costly. They use perspective. So even automobile cannot bear that much cost, but aircraft in dangerous situation. So for them, costly machine like a gold, they can be by machining. We cannot waste that, and we cannot waste that material because that is costly, right? So similarly, those are the aeronautical industry. Not only for the another one of the first industry to adopt this additive manufacturing. Still they are the major contributors to improve this kind of technology. So not only this material, we can use food material to make chocolate 3D printers are there, or pizza making 3D printers are there, like that. There are so many we can use for. So what is the advantage of that? It is only thing, it is design. So some enthusiastic peoples will like those things. Of design, if you see the Western countries or Dubai and all, if you see, the buildings will be very uneven, not like a square and just a balcony, not like that. It will have a very fantastic design. How to design these kind of things? They can design. So it will, and again, are using CAD systems feature. So we might know only those kind of features to create a model, but there are so many things. It can programmatically create these kind of models. So those things that we cannot make. So here I given one picture, gun printed. It is just for fun. Actually, if when 3D printing technology entered into the market, US had one policy that conventional manufacture a gun, because conventional they should have proper license to make a have at home 3D printers. They can make a parts and they can assemble it. It will fire. It will also again fire. Say original gun firing 100 shoots, then if it is firing 20 shoots, then it is again a dangerous thing, right? Then they implemented the policies, should not make a gun like just given a fun. So possible, and make a prototype, and real things are possible with additive manufacturing, help of additive manufacturing too. Yeah. So for example, this car is car is made up of additive manufacturing. So this most of, if you can see, most of the parts are additive manufacture. It is you can see world's first 3D printed car. It is made in 44 hours. That's all. So suppose if we can manufacture a car, but think about it, 2000 parts or 3000 parts are there in the car, and each part has different variations, and how many crores we need to spend. But how automobiles are giving that big that car in 5 lakhs or 10 lakhs, because only because of this competition and using these kind of technologies. So this is a supercar. Again, it is using additive manufacturing. The chassis and some of the additive manufacturing. You can media to get this information if you want. Yeah, some shoe companies like Nike, Adidas are entering into the new design and aesthetic design using additive manufacturing. So it is possible, because so they say, for example, this the man handling the man having one Nike shoe, or this shoe is special. Actually, it is weightless, and it is designed for a particular person, and it has a special purpose, right? So without additive manufacturing, it may not be possible. Process to hand or leg has some problem with the accident, then earlier how to manufacture this is unique. It cannot be fit for anyone else. So on that case, so additive manufacturing is helpful. Okay, it is helping a lot actually. So you can make unique components like this. No need of die or nothing. So if it is mass production, then definitely we will go for a conventional manufacturing. But these kind of thing, unique components, we have to choose additive manufacturing. Yeah. Not only that, say construction industry. Buildings are made up of additive manufacturing. So this technology is coming up. There are quite few companies market. They are these kind of buildings in additive manufacturing. So it is simple. Technology is same. It is layer by layer, and stop machine. They are put XYZ. That's all. It will build the 3D parts. Of advantages, it can be quick. You might seen like recently the coronavirus, China, the Wahoo city, they build the isolation wards and all using 3D printer. So that and all easily it is possible, right? So that is the main advantage of this kind of technologies. Not only that, using this technology for, and yeah, so medical industries, so medical and jewel industries are using these technologies to reduce their lead time. So if earlier if you go to jewelry shop, then they will say they take more time and they will get the design and they then finalize. But nowadays, if you go next day, if suppose they have this kind of rapid prototyping machine, they can give the prototype, they can convince us, or they can say whether it is the designs are okay or not, then they can go for full production. So this is one example of food industry, how aesthetically can design the food and prepare and manufacture the for chocolate, etc. Not only that, say medical industry or either engineering or any stream, so they can use it this technology for preparing the model and explain to the student. So say without these models it may be hard, but if you give the model to the student's hand, they will feel it. So how heart is functioning, how what are the different walls are there, so kind of things they can feel it on the hand instead of seeing in the picture or video. Even engineering, so instead of saying one gear assembly gearbox, if you make a gearbox in rapid prototyping, it is quick, we have all machines, then if we make it, then we can show it to the student so that they will be happy and they won't forget also, so because they felt technology. So those kind of using 3D printing. Yeah, so this is again the skull replacement. This is again unique, say some accident or some reason it is every skull has damaged, then we can use this technology to make the specific design skull, and we can replace. People are using it. Even India also, there are some companies are doing in Mumbai. They are making this kind of it will they mostly they will go for metal parts, and they will design for unique component. Unique means that particular part will not fit for any other, so it will be only it can be only used for the particular person. So that kind of component we cannot make die, it will be costly. So these kind of 3D printing can be used to do. This is something of say so why I given this picture is, say we are going to hospital, we are taking MRI scans, say for various reasons. So those scans can be used to make a 3D model. Those 3D models can be used to print components like this. That is again possible. So there are yeah, there are some in CAD and CAM software itself, they have some options to clean up this some unwanted data, and we can make finally useful for memories. Yeah, recently we know how this technology additive manufacturing helped for corona cases, so making masks and ventilator valves. These are all highly demanded things. So even I have quite few friends in they made these kind of things in thousands, and they distributed to the policemen or doctors, so that they will be happy and they are safe from this kind of problems. So if you see history, this is not evolved in one day or one decade. It took long. 1980, the first technology 3D printing is patented at 1980s. So it took decades to come up to this level. So even we might see at our college days, we might see in lab level. It is not evolved. Now last 10 years only it is evolved. The main reason is the patent got expired, so people are using. So now this technology is all individual like me and you. So we can play with this technology. So there is no patent problem. Yes, again there are some big companies are doing a lot more than what today. So so that improvements always will comes. So for that it will evolve over the period. So it will not be in one day or one decade. It will take multiple decades to come up to this stage. Okay, what next? Okay, we are having additive manufacturing under CAD, CAM, CAE tools. Is it stopped? No. So it has lot more to do. So this is future. So far what we discussed is what is current and what is past. So what is next in this? Say functionally graded material. So functionally graded material, to manufacture a functionally graded material, right now there is no straightforward mechanism or manufacturing technique. So I will go few more slides. What is functionally graded material, why it is required? So I will go few more slides so that you will understand. So these kind of functionally graded materials not possible easily manufacturable in today. So it should be possible. So functionally graded material means I have one component. I at one end I have one material. I have a copper. The another end I have stainless steel. That is my only single component. It is not welded, not assembled. So it is a single component. It has one end, one material, one composition. We can say one composition, chemical composition, and at another end it has a different composition. How to manufacture this? It is very difficult, right? Do we have any application? Yes, there are so many applications. I will go through the following slides. Yes, this has so many applications. It is very functional. That's why it is called functionally graded. Say, manufacturing. Yes, it is possible to make functionally graded material. Not only functionally graded material, we can make a material means it is not a functionally graded. So for example, of the cube will be in one material and another 50% will be in another metal. Not necessarily by 50-50, or it can be partially portioned. It will change also. It is not, if say if it is exactly 50-50 or at breaking at one layer, one section, then we can weld it or assemble it also. But sometimes it can be uneven. So those kind of places this additive manufacturing can help. So that will be the future. And composite material. So this composite material, we know aircrafts are using composite material. 50%, more than 50% of the aircraft parts are composite material. Why composite material? The reason is it is very lightweight. Say for example, I hope you might seen, if you go to some cycle shops. So if you take some this normal cycles, it will be 5,000, 7,000. If it is a aluminum alloy kind of material they used for frames, then it will be 15,000 or 20,000. If it is a composite, that is the difference. Yes, it is a lightweight and it has more functional. So that's why people want this kind of composite material. But how make it right now? Even BMW is making its frame. I think i3 or some model, I forgot. So that model is making a frame in composite material, but it is not that it is hand molded. So that is the problem. Much time and will be more. But using additive manufacturing, it is possible easily. Yes, there are quite few companies, startups, and they are doing and successfully they are running additive manufacturing. Composite material for robotics grips and fixers. So if you say fixers, we know they are using fixers for uneven parts. Hours they can make, but if you make it in plastic, that is a problem. If you make it in metal, that is very costly. So how to optimize that? So we can go for plastic composite material. So that if it is a polymer composite, then it will enough for fixers. So those kind of things are possible today, but the companies are people are very less, but there are quite few people are using this additive manufacturing for making the composite materials. Okay, so FGM, say the application is huge. Where is the application? Say our body bones are a kind of FGM material. Say if we take a bone, inside it will have a porous and outside layer porous will be different. Inside it will be densified and outside the porosity will be less. So this is our body part, nothing but a FGM. That's why our lightweight, bone is lightweight, and we can perform very well. So like that, there are so many applications are there. Say aircraft wing is another and it has, say for example, this IC engine the IC engine components can be a functional grade material. So there are so many things. So the reason is, if we can, manufacturing technology can make this, then there are so use this kind of technology. Right now it is using very. So once if we manufacturing technology make these kind of components, then definitely kind of technology. So additive manufacturing is one manufacturing technique to manufacture this FGM using FGM materials. Yeah, porosities and different nature, and this is nothing but FGM want to replace our bone replacement or those things. If we could make a functionally graded material, then it is lightweight and it is less problematic, right? So there are, but this is again not new technology. FGM is invented in I think 1980s or 90s in Japan, some researcher, and because there is no manufacture, even CNC was not that much evolved at the time, so they're progressing like that, slow. But some technology like additive manufacturing pick this opportunity, then it will become very powerful. Yeah. So this is how additive manufacturing works in dentist. Say it is not only manufacturing; it is used for doctors also, right? So if we go to dentist, then they will ask for multiple visit. For we need to go for track what is the status, and we need to make the mold, and they will prepare for fitting to us. At least 5-6 visits we need to do. These implants are possible, but using it is, we can reduce the number of visits, and it will give immediate solution. And doctors also, not only dentist, any doctor, if any problem in brain or heart, they can prepare a model and explain to the patients that this is the problem, it has to be operated like this, like that. Not only for that, say this if it is taking, if we take root canal, it is not 100% accurate, not 100% successful. It will be either 98 to 100%. So using this kind of technology, we can accurately plan the operations, where we have to put the fixers and clamps, and where we need to drill. All those things doctors can plan and avoid the failure rates. So not only dentistry, any brain operation, heart operation, everything doctors can plan by real model, where the doctor, where they have to tear it, where they have to drill it, all those things. Operation they can, virtual operation, not where it is a kind of real or virtual in between too. So it is possible. So the problem is, I used to ask doctors whenever I go to hospital, sometime I say, oh, doctor, why are you not using these kind of things in these applications? Then doctor will say, we don't know, we don't know design. That's what their answer, because they don't know design, how to design and how to use it. But these industries are coming up, so we have to, doctors one day will make must use of this kind of technologies. Okay, so this is other some applications of FGM materials. Yeah. So okay, fine, we seen what is 3D printing and what is the application and what is those things. What is next? So here it should be possible bio 3D printing. So far, whatever doctors used, whatever I explained, is real normal material. With we can make the component and doctors will use that. But this is bio 3D printing. So the component itself biomaterial. It's called bio ink. So using bio ink, you might see the machine, the very acute, precise machine. So with this machine, they can make this ear. Again, this ear is made up of biomaterial. It will grow day by day. It will grow. It will function. It is living organs, living tissues, living cells. So That kind of things are possible. So there are a lot of research is going on, and even in India, there are few companies are coming in, and this technology, it is called a regenerative medicine. So whenever the tissue or cells are damaged, then they can bring up these kind of things. And right now, it is not possible to heart replacement. We cannot make a heart using today's 3D bio 3D printing, but heart valves are possible with today's technologies. So it will improve, because it is body parts are very functional, and it has a lot of complication. So say for example, inside it will have some property, and outside surface it will have some property. So how to make those kind of components? So as we are a manufacturing or mechanical engineer, we will think in the direction of how to manufacture that. So yes, we have to make the machines like this, so it will be more precise, and it will be useful for the society. Yeah, right now they are making many parts, and they're trying, not exactly they're replacing, they are using animals for testing nowadays. And some they are theoretically they can make anything, body parts. So it can be, we can make the body parts with the living organs, tissue, cells they will make. So how they are making is simple. Say I have a valve problem. So then valve problem, we cannot take a cell from other parts. We cannot take a cell from skin and use that cell for valve printing. So they will take a small one cell from the valve outer surface, and they will multiply that cells. So and they will prepare a bio ink, and those inks are used for printing that component. So how they can print? They will get the design either by, as already told you, them scanning technique, MRI scanning, or like that scanning technique. They can get the 3D model. So they have a 3D model, they have a ink, bio ink, they can make a component. So that is the, theoretically that is the logic, and they are some level they are successful, and a lot of research is going on these areas. Yeah, so this is something. So this is some of the my trial and prototyping. I used to play with these kind of things using multi-material, multi color printing, etc. So okay, opportunities. So I explained so far so many things. In this, so many complications, and so many say machine learning, and IoT. So all are required here. So whenever we model it something, it automatically, if you want to model it, so it has to learn something, and we have to use artificial intelligence or machine learning, and we need to use IoTs. So IoT manufacturing, or IoT in CAD system itself, we can place a IoT system, say any sensors, and those things will perform logically. So before going for manufacturing, we will place those components in a thing. So there are so many opportunities. We can explain these are the many streams available, and there are so many opportunities. Yeah, we want students for young engineers for these various fields. So what they need to know, simple, they need to be strong in mathematics, they need to be strong in some programming language, and these are some basic requirement. So they can be well fit into this. The markets or industries are looking for those kind of people. Yeah, thanks for listening.
Thank you, sir. Dear participants, if you have any queries, then you can unmute yourself and raise your valuable questions to our speaker. So dear participants, if you have any queries, then you can unmute yourself and arise your valuable questions to our speaker.
Sir, good evening, sir. I am one question.
Yes, sir.
Yes, sir. Actually, you are very clearly explained the CAD, CAM, CAE part and additive manufacturing part. I have one question like nowadays in our local industry like Coimbatore, in and around we have 400, 500 foundry industries are there. So normally they are using of sand molding pattern and this kind of conventional manufacturing systems. The surviving of this number of people surviving is based on the conventional systems that are manufacturing foundry industries like pump industries, so like etc. So how the
Yes.
that additive manufacturing, how can it can be replaced or that foundry jobs, or it will give some advancement in the foundry jobs. So I want to know some clarification, sir.
Okay, sir. So basically, now if we want to foundry for manufacturing common, say for example, if you see Coimbatore, it is exporting I don't know current data, but at least 30% of the pumps are exported from Coimbatore. So though and wet grinder invented in Coimbatore. So like that, there are so many histories. But how they made those components are using foundries. So that's why there are so many foundries in and around Coimbatore. So,
okay, sir.
So for foundry, to make some casted part, sand molding is the first thing. And to make a sand mold, we need a pattern, core, all those things will come into picture. So
Yes.
using additive manufacturing, we can make a patterns. Using additive manufacturing, we can make a core. Using additive manufacturing, we can make a sand molds. So these can be replaced. What is the advantage? Ultimate advantage, our main objective is to reduce the cost. One thing, not only that, reduce, some people want very quicker, so it is possible in quickly. So if we go to pattern maker, they will take 2 weeks. If we do it in additive manufacturing, it will be in few days or few hours.
Yes,
So
sir.
those kind of things are possible. And conventional pattern maker or conventional mold will have again a conventional design, but here we need a unconventional things also sometimes, that is again possible.
Okay, sir. Okay, sir. So these are all possible. Then we can expect next at least 10 to 10 years or 5 years back, we can expect in our Coimbatore. We see a lot of industry, foundry industries with additive manufacturing setup. Isn't it, sir?
Definitely, surely it will come, sir.
Oh, thank you. Thank you so much, sir. Thank you, sir.
Yeah.
Any questions? Please ask any questions, participants, please, sir.
Hello.
Hello. Yeah.
Sir, can you share your PPTs? It is more informative, sir. Please share it.
Sir, your voice is not audible.
Can you share your PPTs, sir?
PPT?
Yes, sir. PPT. Yes, sir. Yes,
Okay.
yes.
So which slide you are looking for, sir? Hello?
So he can ask whether you are hand over the PPTs or not.
Oh, okay. So I will hand over the PPT, sir, soon. So I will give it to you so that you can check.
Okay, okay. Thank you. Thank you, sir.
Yeah.
So any other queries? So dear participants, if you have any queries, then you can unmute yourself and arise your valuable questions. So I think there are no more questions. Thank you, so for your marvelous speech with the continuous bombardments of your technical words through which our attendees may grasp an innovative idea in manufacturing sectors. Now I request Professor Dr. N. Thiruvangadam from Mechatronics Department, K.S.Rangasamy College of Technology, Tiruchendur, to conclude today's session.
Yes, sir. Thank you, sir. Thank you. So it is my immense pleasure to thank our today's chief guest, Dr. Saravanan Varadaraju. So he has explained very clearly about the CAD system, collaborative design, then generative design, drop test virtually, and a CAD CAM run the factory, virtual factory. Then now that is a present day expectation, how the single platform can use the all the operations like design, analysis, CAD, PLM, CAE, etc. Everything we can do in single platform. So only one thing is the license only we can get for this whole platform. So we can very clearly understand that single platform license and like a team center, PTCB, windshield, life cycle management system, then additive manufacturing, like number of softwares. So he has explained very clearly about the new words like new types of additive manufacturing like material jetting. So MJ, that material jetting, this is a new term for us. Then EBM also, electron beam melting. Then this SLS and SLM are already we have familiar with thing, but material jetting, then electron beam melting are new things to hear to us. And just 44 hours, this is an amazing thing, information he has shared with us. So just 44 hours, one car can be manufactured using additive manufacturing. It is a very wonderful information. So similarly, number of shoe companies and special manufacturing companies in even food industries, medical industries, fashion industries, number of applications he can delivered very informative. And that particulars nowadays current situation like corona and COVID-19 situation, special isolation ward can be making using a 3D printer is very informative. The China did that particular technology, and also I have here like China have built an office, government office within 44 hours or something. So they are did very latest. They are using that latest technology in 3D printing. So like this number of informations we have get, and the functionally graded materials. These also we don't expect that part, but he also touched the functional graded material applications and medical applications, lot of medical applications. So we could very familiar in this particular topic, and we hope we understand that this particular topic is closely related with our mechatronics. Today's topic is mechatronics engineering for industry 4.0. Also he has touched the IoT, how it is related to all CAD CAM CAE part. So everything he has clearly explained. And what is next, that part is very interesting. So what is next? So bio 3D printing. So bio ink, this is a new term to hear us. This is a bio ink. So bio 3D printing, 3D printing organs, that will be growing day by day. This is a very informative. So and a lot of researches are going on. So the day by day on material, suppose as an engineering material we are developing for doing without any sense, but that is sense means that real sensitive manner. But the day by bio ink or biomaterial day by day it is growing, means we are the wonderful technology we have, and we are doing we have to involve in that particular research and development in futures. Then regenerative medicines, that is also very important information, sir. It is a very great pleasure to thank from K.S.Rangasamy College of Technology Autonomous, Tiruchengodu, and Department of Mechatronics Engineering, and MHRD Institution Innovation Council. So we are very glad and thank you so much for your wonderful presentation, sir. So we welcome you, our institutions in physical mode after the corona issues. Thank you so much, sir.
Thank you, sir. Kind attention to the participants. Day 1, session 2 feedback link will be posted through WhatsApp group and Telegram. For getting e-certificate, you have to fill it. The link will remains open only for 1 hour after completion of this session. Instruction to the participants. Tomorrow forenoon session topic is electric vehicle and industry 4.0, delivered by Dr. P. Sridharan, Associate Professor, Vimal Jyoti Engineering College, Kannur, Kerala. So participants are requested to join with us through Microsoft Teams on tomorrow sharply on 11 a.m. For day 2, from 10:40 a.m. onwards, we start to append the participants through virtual mode. Once again, I thank all the attendees for patient listening. Now today, day one, second session of 1 week FDP on Mechatronics Engineering for Industry 4.0 era was wind up officially. Thank you to one and all.
Thank you, sir.
Yes, sir. Thank you. Thank you so much, sir.
So dear participants, kindly